Welcome to the Explainer. So today we're looking at one of the absolutely most fascinating shifts in tech right now, the anatomy of AI agents. We literally hear this term everywhere, right? But figuring out how they actually function and why they are fundamentally different from what we've had before, well, it's a pretty incredible rabbit hole to go down. Let's just dive right in. Here's the million-dollar question we've got to address right out of the gate. Are AI agents just glorified chatbots that we slapped a fancy new name on? Or are we looking at the dawn of a totally new, autonomous digital workforce? As we unpack the source material today, you'll see the distinction is huge. We're moving from software that simply talks to us to software that actually does things for us. Here's our exact roadmap for today. First, we'll go beyond the basic bot, then look at the anatomy of an AI agent, explore the types of AI agents, check out the benefits and use cases, dive into the real-world challenges, and wrap up with building on Google Cloud. All right, Section 1, Beyond the Basic Bot. To really clear up the confusion here, it helps to look at these three tiers of AI. Think about your standard bot. Its whole purpose is strictly automating simple, predefined tasks, right? It's totally reactive. You type a command, it follows a rule. Then we step up a level to the AI assistant. Also reactive, but it's capable of helping with tasks while you make the final decisions. But the AI agent, that is a massive paradigm shift. Agents are autonomous, they're proactive, you just give them a goal, and they figure out exactly how to achieve it on their own. Moving on to Section 2, Anatomy of an AI Agent. Let's look under the hood. Now that we know agents are proactive, the crucial thing to understand is something called the REACT framework. This is essentially the fundamental DNA of an agent. REACT stands for reasoning and acting. Basically, it means the agent is operating in this continuous loop. It uses logic and context to draw conclusions. That's the reasoning part. And then it actually performs tasks based on those decisions, which is the acting part. It completely bridges the gap between digital thought and digital action. It's kind of like a chef tasting a soup, reasoning that it needs salt, and then actually grabbing the salt and acting on it. It observes the results and just keeps refining its plan to hit that goal. To actually pull off that REACT framework, every sophisticated AI agent out there relies on 4 foundational pillars. You can think of these as the vital organs of the agent. We've got persona, memory, tools, and the model. Let's zoom in a bit on what makes these pillars so powerful. First up, let's talk about memory, because agent memory is absolutely fascinating. It is not just some static database where facts get dumped. Agents actually maintain context over time. They have short-term memory for immediate tasks and long-term memory for historical data. They even utilize something called episodic memory to recall past interactions and learn from them. But honestly, even more impressive is consensus memory. This is what allows them to share information and align with other agents. It's this genuinely remarkable concept where they're essentially building a shared experience over time. Crazy, right? Next, the large language model, or LLM. This acts as the brain of the whole operation. It handles all the reasoning and language processing. But, a brain trapped in a jar can't accomplish much in the real world. And that is exactly where tools come in. Tools are the functions, APIs, or external resources that the agent can manipulate. If the LLM is the brain, the tools are literally the hands. The agent uses its brain to figure out which tool to use, whether that's, say, searching a database, sending an email, or executing a block of code, all to achieve its assigned goal. All right, Section 3, Types of AI Agents. So, how are these things actually assembled? Well, one way to categorize agents is by how they interact with us. On one side, we have interactive partners, sometimes called surface agents. These are user-facing. Think of your highly intelligent customer service agents or digital tutors that fulfill direct queries, but with a ton of autonomy. Then, on the flip side, we have autonomous background processes. These operate totally invisibly behind the scenes. They're event-driven, not user-driven. They do things like optimize supply chains, analyze massive data sets, or proactively fix IT issues, all without any human interaction triggering them. We can also look at this through the lens of scale, single agent versus multi-agent systems. A single agent works beautifully for independent, really well-defined tasks. But scaling up to multi-agent systems? That is where things get really fascinating. Here, you have multiple AI agents collaborating, or sometimes even competing, to achieve a really complex objective. And because each agent in a multi-agent system can be powered by a different foundational model suited for a specific role, they can actually simulate human interpersonal communication. They can debate each other, specialize in different areas, and even cross-check each other's work. Which brings us to Section 4, benefits, and use cases. So, why does all of this actually matter to you? When you put this tech into practice, the benefits are immediately clear. Organizations are seeing absolutely incredible leaps in efficiency and productivity simply because agents can execute tasks simultaneously and automate super complex, repetitive workflows. They drastically improve decision-making too. In those multi-agent systems we just talked about, agents can debate ideas and refine their reasoning, which avoids errors a single model might make. They tackle complex problem-solving by combining different strengths, and they can even model human-like social behaviors to run incredibly realistic simulations for research or strategy. Just to ground this in reality, imagine a modern business ecosystem. You've got customer agents delivering highly personalized support right on the front lines, while employee agents are seamlessly streamlining internal HR queries behind the scenes. Meanwhile, creative agents are drafting your marketing copy, code agents are acting as code developers writing actual software, and data agents are analyzing the massive data sets all of this generates. And wrapping around that entire thing, security agents actively overseeing threat detection to keep the whole operation completely safe. It's a game changer.
Now, let's look at Section 5, the real-world challenges.
To maintain a balanced perspective here, we have to ask a pretty critical question. What happens when agents fail? As much as we talk about their amazing autonomy and capabilities, these are definitely not infallible systems. So let's impartially explore some of the documented limitations where this technology currently struggles. First off, they lack deep empathy. Yes, they can simulate polite conversation, but agents struggle significantly with nuanced human emotions. They literally cannot genuinely read unspoken cues or navigate delicate social dynamics. So for tasks requiring deep emotional intelligence, like therapy, advanced social work, or really complex human conflict resolution, agents just do not possess the required depth of understanding. Secondly, and this is absolutely crucial, there are severe limitations when it comes to situations with high ethical stakes. Remember, agents are fundamentally driven by data and algorithms. They completely lack a human moral compass or the capacity for profound ethical judgment. Because of this, deploying them in sensitive areas, like law enforcement, high-stakes judicial decision-making, or critical healthcare diagnoses, presents some very significant and widely recognized risks. Finally, while agents absolutely thrive in highly structured digital environments, they currently falter in unpredictable physical spaces, navigating dynamic, chaotic environments that require complex motor skills and split-second physical adaptation. Think of emergency disaster response or complex physical construction is still a massive hurdle for embodied AI agents today. The physical world is just a whole lot messier than a database. And finally, Section 6, building on Google Cloud. So how are developers actually building and deploying these systems to overcome those hurdles today? Well, many organizations are relying heavily on Google Cloud to make this happen. Think of it kind of like building a digital factory. Cloud Run acts as the engine. Because agent logic is so resource-intensive, its ability to scale compute power up and then down to zero when it's idle is highly cost-effective. Developers then use the Gemini Enterprise Agent Platform and the Agent Development Kit as their blueprints to build the systems. And finally, the ADA protocol acts as this universal translator, ensuring all these different agents can seamlessly talk to one another. We are moving so rapidly from single chatbots to entire ecosystems of autonomous software workers. As these agents begin to collaborate with other agents, cross-checking data, utilizing specialized tools, and debating solutions in real time, the possibilities are honestly pretty staggering. So keeping this conceptual framework in mind, what complex real-world problem will you ask them to solve first? Thank you so much for joining me today to explore the anatomy of AI agents. Keep learning, keep questioning, and I'll see you in the next explainer.